This will go ahead and help you revise the econometrics well. Let me also go ahead and take you through these formulas once. So this is the formula of simple regression B2. So when your regression model is yi is equal to b1 plus b2 x2y plus ui, when this is your regression model, then in that case, the formula of B2 is summation xi yi by summation xi square. This can also be xi and yi's are in their deviation form. So they can also be xi can be written as xi minus x bar, yi can be written as yi minus y bar. So you can also go ahead and write them in this format divided by summation xi minus x bar square. You can also write B2. This has been asked many times in exam. You can also go ahead and write B2 in the raw form. So if you write B2 in the raw form, it will be summation xi yi minus n x bar y bar upon summation xi square minus n x bar square. This is another way to write B2, right? So again, just for new students, in case you want this entire PDF of 50 plus formulas, you can quickly go ahead and message Rohit sir on 83686 63950 and you can get access to this PDF, which will help you in the revision of econometrics. This is the PDF which contains the formulas for all the econometrics chapter that I have prepared this morning, and this will be very useful for your final econometrics revision. Okay. Now let me go to the formula of B1. So B1 can be written as y bar minus B2 x bar. Now this is just something that can also be asked in true false beta. So whenever we have the product of summation EI xi, x is in the absolute terms, then their summation of the product is 0. Okay? This also means that the covariance between EI and X will be 0. This also comes as a true-false statement. Okay. Now, these are the normal equations. These normal equations are very, very useful. And a lot of times they can be asked in exam. So, dekh lo zara dhyan se. In two variable regression model, this is normal equation 1 and this is normal equation 2. How do we achieve the normal equation? कैसे मिलती है हमें normal equation? Normal equation can be achieved by doing summation. Whenever you go ahead and differentiate summation EI square by B1 equated to 0, differentiate summation EI square with respect to B2 and equate it to 0. So whenever you go ahead and do this, that means whenever you follow the process of ordinary least square, OLS, that is when you will get these two normal equations. This is the first normal equation and this is the second normal equation. There is another way to remember the normal equation. अगर आप देखो तो यहाँ पर second equation में xi has been multiplied. यहाँ पे second equation में xi आ गया है, यहाँ पे भी second equation में extra xi आ गया है. So that is just a way in which you can remember the normal equations. Okay. Formula number 5 beta, the sum of the error terms is 0. Again, this can be asked as a true false statement that when the sum of error terms is not 0. So if you do a regression थ्रू ओरिजिन मॉडल बेटा, अगर मेरा रिग्रेशन थ्रू ओरिजिन मॉडल होगा तो उस केस में द सम ऑफ द एरर टर्म मे नॉट बी 0. Just remember this thing. ठीक है? Again, these statements are very common statements asked in the true false statement. Okay, now this is the next formula which is summation EI xi equal to 0. कैसे different है बेटा? When we talk about equation number 3, in this xi is an absolute form. And when I talk about equation number 6, in this xi is in the deviation form. तो ये वाले को हम ऐसे ओपन अप कर सकते हैं, समेशन ई आई एक्स आई माइनस एक्स बार, ठीक है। सपोज दिस कम्स एज अ प्रूफ कि प्रूफ समेशन ई आई स्मॉल एक्स आई इज 0, तो दिस विल बी समेशन ई आई एक्स आई माइनस एक्स बार समेशन ई आई, एंड वी नो कि समेशन ई आई एक्स आई इज 0, हमने अभी ऊपर लिखा, एंड वी नो कि सम ऑफ द एरर टर्म इज ऑल्सो 0, तो दिस विल बी 0 minus 0, that means 0. So we can say that summation ei small xi will also be 0. Okay, now this says that summation ei yi hat, where yi hat is the predicted value of y hat is predicted value of y, so summation ei yi hat is also 0. But this says that mean of y and yi hat is the same. तो अगर हम mean of y निकालें actual y या mean of predicted y निकालें, तो both of them actually mean the same thing. This says whenever you find deviation of any variable and sum it up, it is 0. So this means that summation xi minus x bar is 0 and summation yi minus y bar is also 0. Okay. Formula number 10, this is the variance of B1. The variance of B1 can be written as summation xi square into sigma square. But I will take n here. मैं n को यहाँ लिख रही हूँ. यहाँ पे डिनोमिनेटर में समेशन xi स्क्वायर इंटू n. द डिफरेंस इज कि जो न्यूमरेटर का समेशन xi स्क्वायर है दैट इज इन द रॉ फॉर्म, और जो डिनोमिनेटर का समेशन xi स्क्वायर है दैट इज इन द डिविएशन फॉर्म, दैट इज इन द डिविएशन फॉर्म, ठीक है। अच्छा, वन थिंग दैट आई वांट टू गो अहेड एंड आई वांट टू अगेन री-emphasize that in case you want this entire PDF of the formula sheet, you can go ahead and you can text Rohit sir on WhatsApp him. Please don't text him. WhatsApp him on 83686-63950, and you can get access to all these 50 plus formula PDF sheet. It's a 19-20 page formula sheet, and it will help you to revise your econometrics. Okay. Now let's go ahead. So if I were to go ahead and find out the standard error of B1, the standard error of B1 will be under root the variance of B1. तो इसका अगर मैं under root निकाल दूंगी, I will get the standard error of B1. The standard error of B2 can be written as sigma square upon summation xi square. तो यहाँ पे देखो बेटा, suppose variance of B1 पे focus करो. Variance of B1 पे, if I just focus on variance of B1, so variance of B1 can be rewritten as summation xi square by n into sigma square upon small xi square. And this part, ये वाला जो part है, this is nothing but this is variance of B2. So we can go ahead and we can rewrite this thing as summation xi square by n into variance of B2. This will be variance of B1. This will be variance of B1. So sometimes in exam they ask you what happens when variance of B2 increases. Simple है, अगर B2 का variance बढ़ेगा तो B1 का variance automatically बढ़ेगा. It will also go ahead and increase. This can be asked as an important question. ठीक है. Now we ask about how to find sigma square. और ये sigma square है क्या? So this sigma square is actually the variance of the error term. The variance of error term can be written as summation ei minus e bar whole square divided by n minus k. Divided by n minus k. ठीक है. Now this is, we know that mean of the error term is 0. So this will be summation ei square. ये 0 हो जाएगा यहाँ पे, divided by n minus k, where k is number of parameters. Where k is number of parameters. So this is summation ei square divided by n minus k, where k is number of parameters. If it's a two regression model, माने मेरा मॉडल ये है yi is equal to b1 plus b2 xi plus ui, so k will be 2. If it's a regression model through origin, so k, there is just one parameter, so k will be 1. If it is a multilinear regression model, तो K will be 3. So it depends on what kind of model you are running. Accordingly, you will go ahead and get the value of K. Okay. This is the standard error of regression. Yes, it is asked sometimes in exam. This is important. It is not standard error of B1 or B2. It is the standard error of regression. The standard error of regression is also called as standard error of Y. तो इसमें हम क्या करेंगे? Summation yi minus y bar whole square. That means you are deviating all values of y from its mean. उसको square कर रहे हो. Divided by n minus 1. Denominator में हमेशा n minus 1 रहेगा under root. So when you will find this value, this is called as the standard error of regression. ठीक है? Now, in case you want to do a Z test, the formula of Z test will be B2 minus beta 2 upon standard error of B2. If your null hypothesis is that B2 is 0, beta 2 is 0, so then you can just put 0 here and you will get Z is equal to B2 upon standard error of B2. If we are working with a sample, so sample में हम T use करते हैं. So T test will have B2 upon standard error of B2. And this goes ahead and follows a T distribution with n minus k degrees of freedom. With n minus k degrees of freedom. So in exam, if they ask you to find out the T value, the T calculated value will come from this beta. And उसको compare करोगे T tabular value से, right? Table का value will come from the table. तो you will be provided a table in exam. और वही table में you will be given कि यहाँ पे alpha दिया होगा suppose 0.05. यहाँ पे आपको sample दिया होगा, यहाँ पे suppose 18 given है. Suppose your sample size is 20, number of parameters are 2. So n minus k will be 18. So under 18 and under alpha being 5, you will go ahead and check the value. Right? I have taken one such question. You can just check it on the recorded side of YouTube. I have taken a question and I have also taught you how to read the T table in that. Please do all those questions which I have posted since yesterday. Those questions contain a question on how to read table, how to read T table, and how to go ahead and solve these kind of questions, right? So now try to understand that you have calculated your T value using this. This is coming from the table. Now, if your T calculated is greater than your T tabular, then what you will do, beta? You will go ahead and you will reject null in favor of alternative. You will reject null in favor of alternative. Okay. Now let's talk about TSS and ESS. So TSS can be written as ESS plus RSS. Your TSS is summation yi square, which is nothing but summation yi minus y bar whole square. Always remember to find TSS, we always find the deviation of y from its mean value. So if this is my regression line, right, so remember, regression line passes through the mean values. So I have gone ahead and I have done this as mean of x and mean of y. And now if this is my actual yi, this is my actual yi value, right? So this will be my yi hat, predicted yi, and this will be the mean of yi. So the difference between y and yi hat, this is total sum of square, right? The difference between predicted and mean value, this is what you could estimate. So this is explained sum of square. And the difference between yi and yi hat, this is residual sum of square, right? So just remember this graph. So when I find the gap between yi and mean of yi, that is known as total sum of square. When you sum it, square it and sum it. Similarly, if I were to go ahead and find explained sum of square has two formulas to it. It can be written as b2 square summation xi square, and it can also be written as summation yi hat square. Okay? These are all in deviation formats, beta, remember. These are all in deviation form. So mane that when I am writing explain sum of square, so this is nothing but b2 square summation xi minus x bar whole square. And when I am writing this, this is nothing but summation yi hat minus y bar whole square. Okay, these are all in deviation formats. So explain sum of square can be written like this, and it can be written like this also. The next thing that we have is residual sum of square. Residual sum of square is summation EI square. Now comes R square. R square is ESS by TSS. Explain sum of square का formula I have just picked यहाँ से, and total sum of square का formula I have just picked यहाँ से. So ESS by TSS is R square. R square can also be written as 1 minus RSS by TSS. So this is going to be 1 minus summation EI square by summation YI square. Now suppose someone asks you to only find R, not R square. ठीक है? And आपको सिर्फ X और Y का values given है. You are only given that this is your X, this is your Y, and find R. Right? So what you can go ahead and do is use this formula, which is summation xi yi upon summation xi square under root summation yi square under root. Just remember that whenever I write in small, these are all deviation from means, beta. These are all deviation from mean. Just remember this, right? Okay. Now, another formula, so I've just opened these deviations from mean. Another formula that you need to remember is that R square can be written as byx into bxy. So, mane, suppose someone gives you like this. This came in 2023 paper only. Suppose someone tells you that when y is regressed on x, your model is y is equal to 80 plus 0.5x. And when x is regressed on y, x is equal to 90 plus 0.9y. And I ask you find R square. So just remember that R square will be byx into bxy. So that means that this into this. So 0.5 into 0.9. So this is going to be 0.45. Right? And if I ask you what will be R, it will be under root of 0.45. Now, whenever you take under root, तो आपको जानना होगा कि sign positive भी हो सकता है, negative भी हो सकता है. So we will always go by the sign of byx and bxy. So since this sign is positive, this will be positive. Another thing which is important here is that byx and bxy will always have the same sign. Will always have the same sign. तो ये वाला sign और ये वाला sign same होना जरूरी है. They will always have the same sign. Just remember this. Very important. Okay. Okay, beta. So this is all that I have written. Please read through it. I have told you you can get this PDF from Rohit sir. Just contact him on 83686633950 and he will WhatsApp you the PDF. So just read whatever I have mentioned in between. Okay, now this is your JB statistic, right, which is used for your normalcy testing. Now here in this JB stat, your S represents the skewness and K represents the kurtosis. Remember that when your skewness is 0 and your kurtosis is 3, then it is a normal distribution. It's a normal distribution. Okay, now remember that we have got y hat as the predicted value of y. अगर हमें predicted value of y का mean निकालना है तो बहुत आसान है. So yi hat is beta 1 plus beta 2 x. So e of y hat will be e of beta 1 plus beta 2 e of x. This will be beta 1 plus beta 2 e of x. Right? So suppose I tell you ki e of x is x naught. So this will be beta 1 plus beta 2 x naught. This is simple. This is x naught. So expected value of y hat will be beta 1 plus beta 2 x naught. But what if we need to go ahead and we need to find the variance of predicted y? So this is the formula for finding the variance of the predicted y. Formula for finding the variance of the predicted y. Now this is the formula of r square in case you want r square in terms of actual and predicted y's. मतलब अभी तक whenever we were writing r square was always in terms of x and y's. But if you want r square in terms of y and predicted y, then this is the formula for that, right? So you can write it as summation yi hat square upon summation yi square summation yi hat square. Okay, beta, now let's talk about multiple regression model. So if you have a multiple regression model which looks like this, right? So these are the formulas for B1, B2 and B3. देखो, you just have to remember the formula for B2. B1 तो आसान है. It's just y bar minus B2 x2 minus B3 x3. When it was single regression तो इतना होता था. अब बस B3 वाला पार्ट आ जाएगा minus B3 x3. B2 का अगर आप फॉर्मूला याद कर लेते हो तो फॉर द फॉर्मूला ऑफ B3 आपको सिर्फ x2 को x3 से और x3 को x2 से रिप्लेस करना है. So you just have to remember the formula of B2 and that will help you revise the formula for B3. Remember that whenever you are writing these formulas, they are in the deviation format. So यहाँ पे देखो, this is all in the deviation format, right? Okay. Now this is the variance of B1, B2, B3. Again, beta variance of B2 को अगर याद कर लोगे तो B3 is easy to understand. This is rarely asked in exam. B1 का variance is rarely asked in exam. But अगर मैं B1 के numerator को देखूं, if I just look at the numerator of B1, then you will realize कि this is very similar to the formula of A minus B whole square. जहां पे ये है A square, ये है B square, ये है minus 2AB. So you can go ahead and create this pattern to remember, but variance of B1 is rarely asked in exam. It is rarely asked in exam. Just have a view through it. Okay. Now let's go forward. So this is summation E square, which is nothing but it is called as residual sum of square for multiple regression model. For multiple regression model, this is summation EI square. Similarly, explained sum of square का formula ये है B2 summation y x2 plus B3 summation y x3. Residual sum of square, another formula is summation y square minus. तो बेटा this is very easy to remember. देखो ध्यान से देखने की कोशिश करो. This part is nothing but total sum of square. Total sum of square is the difference between y and mean value of y. And this part is nothing but explained sum of square. So we know now that total sum of square minus explained sum of square is residual sum of square. Isn't it? So this is another way of writing residual sum of square, which is total sum of square minus explained sum of square. And another way of writing the residual sum of square is this, right? So these are the two formulas of residual sum of square. Okay. Now this is the formula of R square for multiple regression. So R square tells us the joint contribution of all x's explaining the variation in y. सारे x's मिलके y को कितना explain कर पाते हैं, that is given by R square. And R square is again nothing but ESS by TSS. So if you see, this is the formula of ESS that I have just picked from here, right? And TSS is nothing but deviation of y from its mean value squared. Similarly, beta, R square को लिख सकते हैं 1 minus RSS by TSS. तो RSS is nothing but summation E square और TSS क्या है, समेशन y स्क्वायर, तो R स्क्वायर कैन ऑल्सो बी रिटन एज 1 माइनस समेशन E स्क्वायर बाय समेशन y स्क्वायर. Now, whenever you have to do joint testing, जब भी आप joint testing करोगे, you will go ahead and you will use the F test. F test is ESS divided by its degree of freedom upon RSS divided by its degree of freedom. तो ESS का फॉर्मूला बेटा हमने ऑलरेडी पढ़ लिया है. This is the formula of ESS. The degrees of freedom of explained sum of square is k minus 1, where k is the number of parameters. Whereas RSS हो जाता है summation E square and the degrees of freedom of RSS is n minus k. Now this is the ANOVA table beta. This ANOVA table uses the same information. तो अगर आप यहाँ देखोगे, this is ESS, RSS, TSS. This is the formula for ESS, RSS and TSS. अभी I have already explained you these formulas. These are their degrees of freedom, k minus 1, n minus k, n minus 1. बेटा ये भी एक, it comes as a true false statement that the degree of freedom of TSS is always n minus 1. So this is a true statement. हमेशा TSS का degree of freedom will remain at n minus 1. It will remain at n minus 1. So this is your mean sum of square, which can be written as this divided by this, right? And RSS का mean sum of square will be this divided by this. Okay. Now, if you were to go ahead and do an F test for R square beta, जहां पे मेरा null hypothesis है कि R square is 0 and alternative hypothesis है R square not equal to 0. So in that case, your F test will be R square divided by k minus 1 upon 1 minus R square divided by n minus k. Okay. This is your ANOVA table in terms of R square. तो अगर हमें ANOVA को ही R square के terms में लिखना है, तो ESS का formula in terms of R square is this. RSS का formula in terms of R square is this, and TSS is this. The degrees of freedom of ESS, RSS and TSS remain the same. और ये mean sum of square है. So ESS divided by degrees of freedom, RSS divided by degrees of freedom. That will be your mean sum of square. Now there is something called as R bar square. R bar square is your adjusted R square. Adjusted R square का formula ये होता है बेटा. It is 1 minus R square into n minus 1 by n minus k. Always remember कि as long as the number of parameters are more than 1. देखो अगर k 1 होगा तो this will become n minus 1 by n minus 1. So it will cancel out. कोई फायदा ही नहीं है. But if number of parameter is more than 1, अगर k greater than 1 है, तो remember that adjusted R square will always be less than equal to R square. Also remember that adjusted R square can be negative. Adjusted R square negative भी हो सकता है. It can also be negative. Okay, now let's talk about restricted least square. तो restricted least square का formula is this beta. Restricted least square means जब हम कुछ restrictions imply कर देते हैं. So for example, if I have my model y is equal to beta naught plus beta 1. Let's take beta 1 here. It's easy. Beta 1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus ui. And I have imposed some restriction. So मेरा null hypothesis is a restriction on beta 3 and beta 4 jointly equal to 0. So I am putting restriction on this and this. So after putting restriction, my restricted model, it will be y is equal to beta 1 plus beta 2 x2 plus u. So the residual sum of square of this model, जो इस model का R square होगा, that will be called as restricted model R square. और जो इस मॉडल का R square होगा, it will be called as unrestricted R square, right? So your F test is unrestricted R square minus restricted R square upon the number of restriction. जैसे यहाँ पे हमने 2 parameters पे restriction लगाए हैं, तो M is 2. I am putting restriction on 2 parameters. So M is 2 divided by 1 minus R square divided by n minus k. Is this clear? So k is the number of parameters in the unrestricted model. तो अनरिस्ट्रिक्टेड मॉडल में नंबर ऑफ पैरामीटर्स आर 4 बेटा एंड n इज द सैंपल साइज, राइट? ठीक है बेटा, सो दिस इज, यू कैन रीड दिस आउट, ये वाला मैंने करवा दिया है, रीड इट आउट। अब इसी लीस्ट स्क्वायर को हम RSS के फॉर्म में भी लिख सकते हैं। सो F टेस्ट कैन बी डन एज RSS ऑफ रिस्ट्रिक्टेड माइनस अनरिस्ट्रिक्टेड डिवाइडेड बाय नंबर ऑफ रिस्ट्रिक्शन अपॉन RSS अनरिस्ट्रिक्टेड डिवाइडेड बाय n माइनस k, डिवाइडेड बाय n माइनस k। ठीक है बेटा, ओके। सो again I am telling that in case you want the PDF of these written notes, you can contact Rohit sir at 83686 63950 and get access to this PDF for your revision. Okay beta, ठीक है। Now let's talk about the next model. So now I want to go ahead and talk about log-log model. So if it is a log-log model, your beta 2 represents the elasticity of y with respect to x. So beta 2 can be written as how percentage change in y due to percentage change in x. And इसी का फॉर्म ये मॉडल भी है, y is equal to a x beta 2, and this model is also called as a constant elasticity model. This model is also called as a constant elasticity model. ठीक है बेटा, ओके। अब अगर आपके पास एक मल्टी रिग्रेशन मॉडल दिया हुआ है इन विच इट्स अ लॉग लॉग फॉर्म, और आपको ये x आउटपुट बोल रहे हैं और y आउटपुट बोल रहे हैं एंड x's आर गिवन एज इनपुट, तो जस्ट रिमेंबर दैट द सम ऑफ दीज कोएफिशिएंट गिव्स यू द रिटर्न टू स्केल। ठीक है, तो इफ beta 2 plus beta 3 is greater than 1, it is increasing return to scale, equal to 1 constant returns to scale, less than 1 decreasing returns to scale. Now let's talk about the growth models. So it is of the form yt is equal to y naught 1 plus r to the power t. जब हम इसमें log on both sides लेंगे तो we will get this model. इस मॉडल में ये जो हमारा बीटा 2 होता है बेटा, अगर हम इसको 100 से मल्टीप्लाई करें we get instantaneous growth rate, और अगर हम ये कर दें एंटीलॉग b2 माइनस 1 इंटू 100, तो बेटा उसको हम बोल देते हैं कंपाउंड ग्रोथ रेट, दैट इज कॉल्ड एज कंपाउंड ग्रोथ रेट। ठीक है, अच्छा, नाउ वी कम टू y इज इक्वल टू बीटा 1 प्लस बीटा 2 ln x, मतलब log इज ऑन दिस साइड, तो बीटा 2 का इंटरप्रिटेशन हो जाता है एब्सोल्यूट चेंज इन y अपॉन द रिलेटिव चेंज इन x। In this case, remember कि हम beta 2 को divide by 100 करते हैं to get it in the same units. Here we were multiplying with 100. Here we will divide by 100. ठीक है। Now बेटा, this question again is asked in exam. तो ये एक reciprocal model है. But how the curve changes as the value of betas change, this can be asked in your exam. So just remember कि if beta 1, beta 2 is greater than 0, then it is in the first quadrant, convex, decreasing. If beta 1 greater than 0, beta 2 less than 0, so it's an increasing function. And if beta 1 less than 0 and beta 2 greater than 0, then it is a decreasing function, but it goes below. इसका जो asymptote होता है वो x-axis होता है. Okay. Now this is a cubic function. Again in exam एक question आता है that does this violate the property of multicollinearity? क्योंकि this is just xi का ही square, this is just xi का ही cube, so does this violate the property of multicollinearity? Answer is no. Multicollinearity only checks for linear relationship, और ये एक non-linear relationship है, so it does not violate multicollinearity. I have mentioned this here, इसको please read out कर लेना. It does not violate the property of multicollinearity. Okay. Now, in case you need U-shape marginal cost and average cost curves, जो हमारे SAMC आता है या AC आता है, so we get those from a cubic total cost function. But for this, there are some properties which needs to be satisfied by beta 1, beta 2, beta 3. These are those properties. So just remember these properties. Okay. Now this is regression through origin model. If it is a regression through origin model, so this is the value of B2, variance of B2 and sigma hat square. यहाँ पर जो B2 होगा, दिस विल बी इन द रॉ फॉर्मेट, मतलब डिविएशन फॉर्मेट में नहीं है, दिस इज इन द रॉ फॉर्मेट. आर स्क्वायर हैज नो मीनिंग टू इट. आर स्क्वायर का रिग्रेशन थ्रू ओरिजिन में कोई भी मीनिंग नहीं होता, इट डज नॉट मीन एनीथिंग. एंड इट मे हैपन कि अगर हम एरर का सम निकालें, इट कैन बी नॉन जीरो. जरूरी नहीं है वो जीरो होगा, इट कैन बी नॉन जीरो ऑल्सो. नाउ लेट्स टॉक अबाउट स्टैंडर्डाइज्ड वेरिएबल. अगर हम किसी भी वेरिएबल से मीन सब्ट्रैक्ट करेंगे एंड वी विल डिवाइड बाय स्टैंडर्ड डिविएशन, वी विल गेट अ स्टैंडर्डाइज्ड वेरिएबल. Subtract mean, divide by standard deviation, get the standardized variable. The mean of a standardized variable is always 0 and the standard deviation of a standardized variable is always 1. Okay, revise this table beta. All of you will have this PDF. Please isko revise kar lena. Just revise this table. Okay, now let's talk about dummy variables. So dummy variable mein this is called an ANCOVA model. एनोवा और एनकोवा में डिफरेंस आता है एक्स का. इफ यू सी एक्स, इट बिकम्स एनालिसिस ऑफ कोवेरिएंस. अगर ये एक्स मिसिंग होता, then it would have been an ANOVA model, right? Okay, so this is the model that is there. अब बस हमने यहाँ पे दिखाया है कि if dummy is, suppose dummy is gender, 1 if male and 0 if female, तो dummy को हमने 1 रखा तो I will get for males, and 0 रखा तो females का आ जाएगा. So this is for male and this is for female. Just try to understand कि इसमें जो ये हमारा β2 है, this β2 is the difference between male and female salary. तो ये जो गैप है, this is β2, और क्योंकि ये सिर्फ इंटरसेप्ट का गैप है, this is called as intercept coefficient. Intercept differential coefficient. ठीक है. Another thing that you have to remember कि अगर ये β3 suppose negative हो जाए, right? That means the slope is negative. So my regression lines will become downward sloping. Okay. Then just read out what is dummy variable trap beta. If there are two qualitative values and you take two dummies, then you enter into a dummy variable trap. Dummy variable trap के अंदर there is perfect multicollinearity and therefore it violates the assumption of the ordinary least square. ठीक है. तो हमें क्या करना होगा कि अगर दो qualitative values ले सकता है, like gender can take two values, male and female, so you will only introduce one dummy. Always introduce one less dummy to avoid dummy variable trap, right? Okay. Now this is the case of interaction dummy beta. यहाँ पे मैंने ये D2 D3 लिया है और इसके साथ ना I have taken D2 1 if male 0 if female, D3 1 if white 0 if non white, और मैंने यहाँ पे 4 regression equation accordingly formulate किए. I have given you 4 regression equation और इसी का ही interpretation I have given here. What happens when you have coincident regression, parallel regression, concurrent regression and dissimilar regression? Just try to read this also. So with this, I cover the formula sheet of your all chapters till your dummy variable chapter. In case you want this formula sheet, you can go ahead and text Rohit sir, WhatsApp him on 83686 63950. He will share this PDF with you. Happy learning. Best of luck for your exam beta. Thank you.